and welcome everyone to lecture 3 of probability and statistics. Today we will learn about expectation and variance of random variable. Expectation of random variable, it also acts like average and it can be denoted by E of x or mu. We can define it for both discrete and continuous random variable. If we will define it for discrete random variable, then it equals to summation over x of x times f of x. And if we will define it for our continuous random variable, it equals to integration from minus infinity to infinity x times f of x dx. Similarly, we can define expectation of g of x, where g of x is a function of x and f of x is probability distribution function for x. E of g of x for discrete random variable equals to summation over x g of x times f of x, and for continuous random variable it equals to integration minus infinity to infinity g of x times f of x dx. We have some properties of E of x. First property is E of ax equals to a times E of x. If we multiply each number with a scalar variable, then our average will also be multiplied with that scalar variable. Our next property is E of x plus b equals to E of x plus b. If we add a constant to each variable, then average of this variable equals to that constant plus initial average. Our next property is E of ax plus b equals to a times E of x plus b. This property we get by combining previous two properties. Our next property is E of gx plus h of x. Expectation of sum of two functions of x random variable equals to sum of individual expectations of that functions. Now we will move on to our next topic. Our next topic is variance of random variable. Let's say we have a random variable x with probability distribution f of x and mu, which is mean of our random variable. Then variance denoted by sigma square equals to expectation of x minus mu square. We can define variance for both discrete and continuous random variables. For discrete case, this equals to summation over x minus mu square times f of x, and for continuous case this equals to integration minus infinity to infinity x minus mu square times f of x dx. Now if we will solve this, we will get a new expression. Let us solve this together. E of x minus mu whole square. This will be equal to e of, if we will open this whole square, x square minus 2 mu x plus mu square. This will be, now we know that mu equals to e of x, because it is the mean and mean equals to expectation of that random variable. If we will open this, this will be equal to e of x square minus 2 mu e of x plus mu square. Now we will put the value of mu in this expression. This equals to e of x square minus 2 e of x square plus e of x square. Now we will add this, then this equals to e of x square minus e of x whole square. So this is our expression for variance. Now we will solve some questions, and our question is, let f of x equal to 20,000 by x cube for x greater than 100 and 0 elsewhere. We have to find e of x. As we know, this is a continuous random variable, and for continuous random variable, our e of x equals to integration minus infinity to infinity x times f of x. Now we have dx. Now we have two intervals. First x less than 100 and second x greater than 100. For x less than 100, our equation will be minus infinity to 100 x 0 dx plus 100 to infinity 20,000 by x cube multiplied with x dx. If we will multiply this, this will be equal to, this will equals to 0, 100 to infinity 20,000 by x square dx. So this will equal to, now we will add this, if we will take this to numerator, this will be 20,000 x to the power minus 2 dx 100 to infinity limits. So x to the power minus 2, this integration will equal to 20,000 into x to the power minus 2 plus 1 divided by minus 2 plus 1 limits 100 to infinity. So this is 20,000 minus 1 by x infinity 100. If we have to cancel out this minus, we will exchange the limits. So this will be 20,000 times 1 by x 100 infinity. So 20,000 multiplied with, if we will put the value of 100, this will be 1 by 100 minus 1 by infinity. 1 by infinity is 0. So this will be 20,000 by 100, and that is 200. So 200 is the e of x and our mean value. next question is we have to find expectation of y by x for given function f of x comma y equals to x times 1 plus 3y square by 4, where x lies in the interval 0 to 2 and y lies in the interval 0 to 1 and 0 elsewhere. We have to find expectation of y by x. As we know, this is for a continuous random variable, so our formula will be minus infinity to infinity minus infinity to infinity y by x times f of x comma y dx dy. As we know that in this interval, if we are not in this interval, then it is 0. So we will only integrate in this interval, because 0 will lead to our integration tending to 0. That's why from integration x lies between 0 to 2, y lies between 0 to 1, y by x f of x comma y equals to x times 1 plus 3y square by 4 dx dy. If we will multiply these two terms, x will cancel out and we will get 0 to 2, 0 to 1, y times 1 plus 3y square by 4 dx dy. If we will solve dx first, then it will be 0 to 1 integration. These whole expression doesn't have a x, so our integration will be y 1 plus 3y square by 4. We will take outside x with the limits 0 to 2 into dy. If we will put the limit, we will get it as 2 minus 0, that equals to 2. So our expression will be 0 to 1 y times 1 plus 3y square by 4, and this is multiplied with 2, so it will be by 2 dy. If we will solve this integration, we will get y by 2 into dy integration. So this will be y square by 4, and our limits is 0 to 1 plus 3y cube by 2. So this will be 3 by 8 y to the power 4 with limit 0 to 1. If we will solve these limits, so this will equal to 1 by 4 minus 0. This is 1 by 4 plus 3 by 8 times y to the power 1 to the power 4, 1 minus 0 into 1. So this will be by 8 LCM, and 2 plus 3 equals to 5 by 8. So this is our answer. Now we will move on to next. Our next question is, we have to find e of xy given that f of xy, this is for x and this is for y. So 0 0, f of 0 0 is 3 by 28, f of 1 0 is 9 by 28, f of 2 0 is 3 by 28, f of 0 1 equals to 3 by 14, f of 1 1 equals to 3 by 14, f of 2 1 equals to 0, f of 0 2 equals to 1 by 28, f of 1 2 equals to 0, f of 2 2 equals to 0. So we have to find e of x y. As we can see, these are discrete random variables. So we will solve this by using summation x, summation y. So x goes from 0 to 2, y goes from 0 to 2, xy multiplied f of xy. Now if we will expand this will equals to, first we will put the values of 0. So when 0 is 1 and y is 0, 0 into 0 f of 0 0 plus 0 into 1 f of 0 1 plus 0 into 2 f of 0 comma 2 plus 0 plus 1 into 0 f of 1 comma 0 plus 1 into 1 f of 1 comma 1 plus 1 into 2 f of 1 comma 2 plus 2 into 0 f of 2 comma 0 plus 2 into 1 f of 2 comma 1 plus 2 into 2 f of 2 comma 2. Now can see, if we multiply this with 0, this whole will equal to 0. So we will cut out that once we have multiplied by 0. So this will be cutting out, this will be cutting out, this will cut out, this is cut out and this is cut out. Now we have 4 values. F of 1 comma 1. F of 1 comma 1 is 3 by 14 and we have to multiply this by 1. So our a of xy equals to 3 by 14 plus 2 times f of 1 comma 2. 1 comma 2, this is 0. So this will be 0. 2 times f of 2 comma 1. F of 2 comma 1 is again 0 plus 2 times f of 2 comma 2. F of 2 comma 2 is 0. So this will equals to 0. So this is 3 by 14. Our value for expectation of xy equals to 3 by 14. So now we are ending our lecture and we will meet in our next lecture. Thank you.